Good morning, good afternoon, good evening. Welcome to Hands on SAP Dev with Q Macro. That's me, DJ. Episode 81. Good morning to Helmut. Good morning, everybody who's joined already, and thank you so much for joining. I've got this headphone set on today because I was doing some testing this morning, and I did notice that the microphone that's on the camera here, on my Logitech camera, which I normally use, it was picking up probably more of the fan noise of this MacBook that comes on when I'm live streaming than I really wanted. So I've done some tests, and I think this audio should be better. When I get my new microphone, that should be even better. I don't have to wear this. But anyway, welcome. Thank you for joining. Christian, good morning to Munich. Jorge, good morning. Helmut, you like to talk about JS basics. So do I. So do I. And it's very opportune that we do, because that's what we're going to be doing today. So great. Andrew, welcome. Greetings to Melbourne, where all is fine. That's good to know. Thank you for joining, Andrew, and thank you for sharing that picture of the coffee, our Hands on SAP Dev coffee. I hope it's good. In fact, I'm drinking the same coffee. So the Miriam Perez Natural. Right now, I've just brewed some up. And in fact, I'm going to go down to the Hart and Graft roastery straight after this, because I've got to go and see my grandma, put some cream on her legs. So I've just got this. So anyway, look after her. So there we go. So howdy, Robertino. Howdy, welcome, welcome, welcome. And let me make sure I get this right. Priyaranjan, good afternoon to India. That's great. Thank you for joining. Thank you for joining, and thanks for the confirmation of the audio, Andrew, as well, and Jodel. Welcome again. It's nice to see you. It's it's only been a few weeks since you joined, but ever since you joined for the first time, you've been here every time. So thank you, Jodel. That's been noticed. Hemsagar, good morning to you, or good afternoon, maybe. I'm not sure. And Mark, bonjour. Ooh, a little bit of French today. Why not? And why not indeed? So yes, welcome everybody. I've got my coffee. I've not got any biscuits. I was going to grab some, but then I thought, oh no, coffee has been splendid, but it's sparkling time now. Yes, Friday afternoon, stroke evening in Melbourne. Yes, it would be sparkling time for me as well at that same time over here. And Nabheet, fellow live streamer superstar Nabheet, welcome. It's great to have you on. I hope everything is well with you. So there we go. We've got some news. Let's go through the news first. Got some very exciting news, actually. Well, I think it's exciting. What else? Yeah, today, just so we know, the title is Growing Functions in JavaScript from Reduce Upwards. I'll explain what that means in a little bit in a few minutes. What's wrong with my brain? But yeah, first let's go through the news. Okay. Priyaranjan, thank you very much indeed. A nice big smile from you as well. Brilliant. My name's a little bit easier to pronounce, DJ. Yeah, which I quite like because it's easy. So yeah, some news. Let me just switch to the main scene, and I should stop doing that. I should do that sort of without saying anything, because and it looks a bit more professional. So back when we started this adventure, the Hands on SAP Dev adventure, that was, and I'm looking at this blog post here, which I wrote on the 16th of January 2019. So well over a year and a half ago. And who knew that we'd still be all together? Who knew that I'd be still live streaming? And also, who knew that some of my colleagues would be joining too, which is awesome, right? So there's me, there's Tom, there's Max, there's Kevin, and we've also, of course, had other colleagues on from our advocates team, for example, Marius. And yeah, we're going to take the next step. So one of the things is that, to watch the live streams that I do, you go to my channel and you've got to, remember to go there, and you got to subscribe to me, and then you've got to subscribe to Tom, and remember to set a reminder on Tom's channel, and to set a reminder on Max's channel for Max's videos, and Kevin's, and so on. So now we're consolidating. we're getting together and we're going to be live streaming from a single YouTube channel, which is, of course, a channel that you probably know about, and you may already be subscribed. If you're not subscribed, please subscribe now. We'll all subscribe together shortly, which is the SAP Devs YouTube channel. So that means that, I mean, we've sort of retired this blog post anyway. Yes, stop watching Netflix and watch this series instead. Yes, exactly. There's some good stuff on Netflix, but you know, there we go. So yeah, we've retired this blog post a good while ago now, but I just wanted to look at this, you know, to see when I started it, and you know, I had no idea what I was going to be doing. Still no idea what I'm doing. And also, I'd been maintaining this calendar of live stream events from my channel, from Tom's channel, from Max's channel, from Kevin's channel, but that was quite a manual thing, and you know, it was a solution. It was a tactical solution, but the strategic solution is we've got an SAP Developers YouTube channel already, right? So please go across here right now, if you're not already subscribed, and subscribe to this SAP Developers channel. We're going to be making the transition over the next week or two. Nappy, can we expect Monday morning thoughts again? You know, I know that you and some other folks have been asking for that. I would like to do something like that again. Maybe not Monday morning thoughts, but maybe something of a similar nature. One of the reasons, you know, I stopped doing Monday morning thoughts because I wanted to start doing the live streams, and my brain has only a limited capacity, very small limited capacity at that. Oh, right. Okay, thank you. Like my labial plosives are coming. I'll move the microphone down a little bit towards my chin. Yes, I'll put it round there. Okay, so hopefully that'll be a little bit better. This is when I get excited. You know, I do that as well. So yeah, maybe I should start another series about. I don't know. Yeah, I've been experimenting with something. I'll tell you about that in a minute. Something slightly different, Napit. But anyway, so please go across to the SAP Devs or SAP Developers YouTube channel. The name of the channel is SAP Developers, and the username nicely is short SAP Devs. I'm subscribed. Please go and subscribe as well. And then eventually, soon, Kevin and Max and Tom and me will all be appearing on this same channel instead, right? We'll still be doing some random stuff on our own channels. You know, maybe for example, I'll be doing some more Raspberry Pi stuff on my channel or whatever, right? But where it's SAP related, we're going to be doing it from this single central channel, which is going to be fantastic, right? So I'm looking forward to that. So that's the big news. That means that, of course, this retired blog post goes away. This calendar won't need to do that anymore, because you'll only need to subscribe to one channel, and obviously the notifications, then you can all manage them, being subscribed to this single central account, which is great. Okay, and the name of the series is going to usefully, helpfully, I don't know, yeah, remain Hands on SAP Dev, not Hands on SAP Dev with Q macro, of course, because it's not just me. So it's going to be Hands on SAP Dev, and there's going to be all the superstars and me as well, idiot DJ, doing that stuff. So yeah, very, very excited to be able to tell you about that. It may be that next week we might see the first episode in this new form. Okay. Good morning, Tim. Good morning, Tim. Just telling people about the nice news that we're moving to the SAP Developers YouTube channel, and we're all going to be live streaming from there. So it's going to be a lot easier for you to follow. So there we go. That's that. What else? What else? What else? SAP Developers done that. By the way, this weekend, Ronnie, did I see Ronnie? No. Oh, no. Actually, no. I was thinking of Ronnie just now, Ronnie Sletter, because Ronnie produced these awesome stickers. And I've got more than these, but I've still got some stickers. So if anybody has not got any of these stickers, which will still be relevant, right? I've got a bitrate warning here, stream health. Oh, it's okay. Will still be relevant for the new SAP Developers Channel hosted series, then let me know. Send me a direct message, for example, on Twitter with your address. And when you send your address, please send it with, like, places where I know there's a new line, because sometimes addresses in different countries are hard. It's like, where do I put the next line? Okay, so tell me what, and I'll send you some stickers. And I've also, of course, got plenty of the awesome developers.sap.com stickers, maybe for your forehead. So yeah, let me know if you're looking for any hands-on SAP dev and or developers.sap.com stickers. I can send some. So yes, the one thing I wanted to let you know was that, for example, this weekend, i.e. tomorrow, for example, we've got some more SAP Online Track goodness going on. So if you're not already subscribed to the SAP Online Track YouTube channel, you should be. So there's another channel to subscribe to. So much goodness coming your way. And yeah, check it out. That's that. One more thing. Some of you may know I've been playing around with. Oh God, that's big. That's a big avatar of my face. Anyway, let's ignore that for now. Some of you may know that I've been playing around with the new or relatively new sort of Easter egg thing on GitHub, which is, you may know this, you may not. Mahesh, good morning. Good morning to Mahesh. Really glad you joined. Thank you for joining. Mahesh, just in case you missed it, we're moving to the SAP Dev channel. So I'm moving, Tom's moving, we're all moving to the SAP Dev channel for live streaming. So if you're not subscribed, scroll up. If you haven't, it's only a few messages up. Scroll up in the chat and you'll see the link to the SAP Dev channel. Please subscribe now and you get all the notifications. So on GitHub, you have repositories, and if you create a repository of with the same name as your user ID, so my user ID is QMacro, and I've got a repository called QMacro as well. If you create that, it's a special repository. The readme.md will appear on your public profile. So that's this thing here. And when you go to your public profile, when you go to somebody's public profile, if they've got a readme in a repo of the same name as their ID, it appears there. How wonderful is that? So already subscribed. Good work, Mahesh. Hope everybody else is already subscribed. So I've been looking at that, and also I've taken some inspiration from an awesome person called Simon Willison. Simon Willison, and who wrote a blog post about. I'll just put a link to Simon's homepage there as well. Who wrote a blog post about dynamically updating his little README. So I've sort of stolen that idea, and I'm dynamically updating this part of my README using, of course, a GitHub action. So if you're interested in that, have a look at that. There's my repo. There's my public repo, and in there, if you have a look, you can do the same. So there's the workflow with the build.yaml describing a job with a number of steps. I'm not going to go through that now. We could do like a Wednesday afternoon episode going through this sort of thing, just explaining what this is and how this works and everything. But that runs basically every 6 hours on the top of the hour, or when I press a button, and it will go and check out the repository, build all the user template, and rebuild, as it were, the README file, grabbing information from the SAP community, my blog posts on the SAP community, the YouTube channel. I'll add the SAP Devs YouTube channel here as well. My blog, my home blog here with different blog posts, and also I've got another blog called Language Ramblings, which I write on occasionally. So there we go. And I've also added a couple of little badges here. This is one from Code Wars, and I've put the badge on the Code Wars badge on here to encourage me to do more Code Wars stuff, which is this great. And there's the Stack Overflow as well, right? Which is this great sort of programming practice website. Really, really cool. So if you're not on Code Wars already, there's Code Wars. There we go. Napit, this job is running on the Raspberry Pi. No, I've got the Raspberry Pi here. It's just there. In fact, I can't really. There's the Raspberry Pi, and it's quite warm, but the case is acting quite well as a heatsink. That's connected to another repo where I'm doing some builds. Okay, so that's not connected to my public repo. In fact, GitHub recommends you don't use a private sort of runner for public repos for security reasons. I'm going to look into that more because I would like to use my Raspberry Pi as the builder, as the runner host for the building of my README. But yeah, there we go. So enough of that. I think that's all the news. It's 8:15. That's just good timing. So let's get on with what this particular episode is about. A bit of a return to basics, partly because I really enjoy the subject, partly because I've been really busy this week, and this is a nice thing to do at the end of the week. I saw a YouTube video. There's a great person, a great YouTuber and Twitcher called CJ, and he has this channel called Coding Garden with CJ. Let me put a link to this thing here. Oops, there we go. I think I put that right. Really awesome series on Twitch, and it puts the videos on YouTube afterwards. And he did one where he basically polyfilled reduce from scratch. Now let's just unpack what that means. Now let's go first of all. While we unpack that, let's look at what reduce is. There we go. That's a bit better. Reduce is a function. And it's a function on the array prototype in Java. We're talking about JavaScript, and we're not going to get into too much about prototypes and everything. But basically, if you have an array object, right, like that, yeah, there's an array object. Why can't I highlight that? There we go. An array object. You can call certain functions on that array object. It's a little bit odd the way that that works. It's not like a normal function. It's a function that's almost like attached to the object type through this prototype mechanism. It's prototypal sort of approach. But anyway, that's a story for another time. Just like reduce is attached to the array prototype, we've got other functions like map and filter and all those wonderful things, right? And reduce. The premise of CJ's video was in some circumstances, IE6, for example. I mean, who would be using IE6 anyway? But anyway, no. I think it was more of an academic exercise. In IE6, Internet Explorer 6. Yeah, like an object, Pedro. Yeah, exactly, like an object. It's almost like, these are the methods that you can call on the object. And the way that you actually define it, the function itself gets given in this variable, parameter, argument, the actual object is the instance that it's working upon. But anyway, we're going to sort of cross that part of the bridge shortly. So yeah, reduce in IE6 doesn't exist, so we decided to write a polyfill. I mean, to me, a polyfill or polyfilla is a product that you can buy over here in the UK, maybe other countries as well. It's a paste that you've got a hole in your wall and you want to sort of smooth it over and paint it over again. You want to fill the hole in first, you put some polyfiller in. Okay, so it's like patching up something. So when you polyfill something, you patch up something. So IE6 has a hole because it's not got a reduce, so we patch it up by putting some polyfiller in there, and there we go. So that's the whole idea of what that video was all about. So that gave me an idea. Yeah, reduce is a wonderful thing. I love reduce. And during the SAP Online Track event back in May, I talked a little bit about functional programming, and I mentioned reduce and all sorts of things. I've got a link there to the slides and everything, which I'm going to share shortly. And I thought, wouldn't it be really cool to have a look at writing reduce ourselves so that we understand reduce more, and then also we can use reduce to pull ourselves up by our bootstraps and implement other functions that operate on arrays, because reduce is almost like, I've said this before and other people have said this, it's not my phrase, but it's a wonderful phrase. It's like the mother or the father, the mother of all functions, array-like functions. It's such a powerful, beautiful thing. So that's what we're going to do. For those of you who don't know, have a look at, and here's I'm not saying go and read this now, but there's the reference. Mozilla Developer Network reference is a fantastic set of resources. But basically, the reduce method executes a reducer function that you provide on each element of array, resulting in a single output value. Now that's actually, yeah, that is helpful for an introductory view of what reduce is, but it doesn't necessarily. It implies that you're reducing something down, for example, from an array, because reduce operates on array, down to a scalar. The classic example is where you might have a well, let's do one now. Okay, I've got something here. What did I do? There we go. I think. Oh no, here we go. About blank. I decided to do this in the Chrome Developer Tools, because Chrome Developer Tools is awesome. So let me know if that's the right size. So if we got a nums equals, for example, 1, 2, 3, 4, 5. If we want to add those up, okay, we can add them up in many ways. Yes, Helmut, that's exactly right. Helmut, reduce is like the Swiss Army knife of functions, okay, and you can implement map and filter in reduce, which is what we're going to be doing, right? So let's say we want to add those up. Let's say we've got a function called add, which takes two things and just returns those two things added together. So if we say, for example, add 1, 2, we get 3. Okay, so far so good. So we can now say nums.reduce with add starting at 0. There we go, 15. I love the sort of the eager evaluation in Chrome Developer. You can turn it off, but for our purposes, it's showing 15 now in sort of a slightly lighter coloured blue, because it's like, oh yeah, like that, and then okay, it goes deep blue when you press enter, because that is the evaluation. Pedro, clearly the ABAP 740 plus syntax was inspired in new JS features. Ah, interesting. Yes, I mean, are you talking about the reducing 740 plus or more specific syntax than that? Let us know. Let us know in the comments, in the chat, sorry. So how does that work? Well, rather than trying to, let's explain very briefly now. What reduce does is it takes, let's sort of express this function sort of explicitly in line as a lambda function. It takes a function. Okay, so reduce takes two things normally. Well, it takes three things really. It takes an array, nums. It takes a function, which we're going to define in a minute, and it takes a starting value, which we call the accumulator. Okay. So what does the accumulator start with? What value? It starts in this case with 0. When we add things together, we want to start with something that's like neutral, which is 0. Reduce and filter. Yes, exactly. It's great to see wonderful functions like reduce and filter come to the ABAP language. So definitely yes. And what happens is that reduce iterates over, using sort of regular list mechanics, iterates over the given array, one element at a time, and passes each time the given element, first element, second element, third element, etc., into the function. But it doesn't just pass the element of the array into the function each time, it passes the accumulator. So the function you have to use, the function you write as your reducer function, should expect two arguments. It should expect the accumulator, and it should expect then also, each time around, one of the elements. Okay, so it's first time around, this function, I'm not, this ... is just, I'm not written it yet. I'm not, that's not the spread. Well, it looks like the spread rest operator, but it's not. It's just like I've not written the function yet. So taking this nums array here, what's going to happen is it's going to say, okay, well, let's starting with 0. So first of all, reduce is going to take the first element, 1, and call this function, right? Passing 0 here as the starting accumulator and 1 there, so passes 0 and 1. And whatever that function evaluates to, that becomes the accumulator for the next call. Okay, so if we're adding, let's do that now. If we're adding this together, a plus x, for example, there we go, x is 15. So 0, it calls it with 0 and 1, which is 1, and then it calls it with 1 and 2, which is 3, then it calls it 3 and 3, which is 6. Then it calls it with 6 and 4, which is 10. Then it calls it with 10 and 5, which is 15. Okay, so that's how reduce works. But rather than try and think about that, in our brains without seeing anything, let's implement reduce ourselves. Now, rather than try and implement it with, in the sort of the prototype style, I think it's going to be easier or simpler and also more beautiful and more appropriate if we implemented reduce like it's implemented everywhere else. For example, if you look at Ramda, the Ramda definition of reduce is like reduce you'll find everywhere else, which is just a normal function. Okay, and this is the function signature. It's a bit weird to look at these function signatures. It took me ages to sort of get my brain around these. But basically, what this is, that's a bit reduce, a bit smaller, a bit bigger. Basically, it says reduce is something that takes a function, it takes a starting value, and it takes a list of things, and it produces something. Okay. So in that way, here's an example. Reduce takes a function, in this case, the subtract function, okay, which is another Ramda function, doesn't matter. It takes a starting value, this accumulator value, and then it takes an array. Okay, so that's the pattern, that's the type of reduce signature that we're going to implement now. There's also a really good reason for having the array last in the list of arguments here. And that's to do with currying and partial application, but we're not going to get into that. So let's implement the simplest possible way. Go to it. There we go. So in the simplest possible way, let's implement a reduce function. So reduce is a function that takes a function, let's call it fm. It takes a starting value, we're going to call it the accumulator, and then it takes an array. Okay, let's call it array. Often I call it x's, right? But let's just call it array for the sake of argument. In fact, I call it x's because I've got this wonderful inspiration from one of the superstars in my learning, who is Eric Meyer. Okay, and he always says x over x's, but we'll maybe come to that later. Okay, what's going? Is this the? This is because I've got the developer tools open on the wrong thing. Here we go. So about blank. There we go. Then we'll have the developer tools. There we go. That's better. Developer tools open there. Right. So reduce equals is a function that takes a function and an accumulator and an array. And let's just write it sort of, fairly mechanically. We're going to do it. Hey, Leo, good morning. Good morning, Leo. Nice to see you. Nice to see you. We're going to write it sort of in a fairly mechanical, simple way, first of all. Maybe we'll stay with that as well. I would like to play around with a recursive way using head and tail and so on, but maybe we'll leave it at that for now. Eric, good morning. Eric Wenberg, good morning. Welcome to HandsOnSAPDev. So, what we're going to do is do the same thing as what reduce does, what we just looked at, which is basically to iterate over all the elements in the array, starting, with this accumulator, whatever that is. So let's just have a for loop. Let I equals 0. As long as I is less than array.length. Okay, this is just normal stuff, but because it's sort of hidden inside our reduce function, which we're going to use then atomically from then on, building upwards from our bootstraps, it doesn't matter that I don't know why, but I've got something against for loops. I don't know why. But this is a perfect place to use a for loop. Very, very basic. Okay. Increment I. Okay. And what we want to do inside this for loop, okay, which of course is iterating I, or which is going through I as far, as the index to each of the elements in the array. We want to say, we want to be modifying the accumulator, right? So we want to say, well, whatever the accumulator was, it should now be the result of calling that function that we're given here, passing in the current value of the accumulator, excuse me, and passing in the individual element, the x, for example. Okay. So each time around the loop, okay, first time around I is 0, so we grab the 0th element of the array. So remember that nums 1, 2, 3, 4, 5. So we grab the 1, and the accumulator starts at 0 because we specified 0 for the starting value for the accumulator. And so the first thing that happens inside this for loop is that the accumulator gets the value of calling the given function that that's passed to the reduce call with 0 and 1. And the output of that is the accumulator. And then next time around, we get 0 plus 1. If it's 1, 0, if it's a plus, then it's 1, and then the next one, and so on. And that should be it. So if we say that we close that loop, and then the last thing we should do, of course, is because we're defining this using the fat arrow syntax for function definitions, but we've got a block syntax, so we've got to remember to use the return keyword to return the thing. So we want to return the accumulator at the end. Okay, and that's it. Now, let's try that now. So reduce. So the pattern that we've defined here is we've got our add. Let's define it again. So let's define it here in front of our eyes so we can see what the add does. Okay, add is a function that takes two things and returns the result of adding those two things together. Okay, so in a way, when we pass the add function to reduce, we're saying A is the accumulator and B is the X, is the individual element each time. Okay, it doesn't really matter what they're called, A and B. So if we say reduce add starting at 0 nums. Nums. What did I call it? Nums equals 1, 2, 3, 4, 5. Oh yeah, of course, because it was in a different Chrome Developer Tools session. I guess I don't know. Nums, right? So let's try that now. There we go. 15. We get 15. So we've defined our own reduce. Okay, so let's go through that a little bit more slowly. Is it worth going? Yes, it's definitely worth going through it slowly because also we get to, and I came across this feature earlier this week by mistake, right? It's Chrome Developer Tools feature. If we look at the reduce function definition, okay, which is it's nice to be able to sort of type in the function name and it shows you the code. If you get your mouse and click on that, you get put into the VM and you can put breakpoints in it. What? It's amazing. So let's put a breakpoint inside this for loop here, okay? Then bring up the sort of console draw here and do that again. So if we say reduce add starting at 0 and nums, well, there we go, there nums, it's eagerly evaluated it. But I think also when if we press enter now, there we go. We're now inside this little VM that's running this code for us. Now, if I move the call stack out of the way, we can see the whole scope of this. So how do I drag that down? There we go, there. It's quite weird when everything's really big on my screen. It's like, where do I click? Okay. Max, good morning to you. Strange Java syntax. Yes, it is a strange Java syntax. I guess everybody knows the story of why JavaScript was called JavaScript. And it does obviously relate to the fact that Java existed at the time. Anyway, let's not go into that. So the first time around, what have we got? We've got the function, okay, which is its add function. We've got the accumulator, which is 0, and we've got our array, which is this list of 5 numbers, 1, 2, 3, 4, 5. So here we've got the accumulator 0 is going to be the result of calling the function that we're given, the add function, with 0 and array of I, which is array of I is array of 0, which is 1. Okay. Oh, we can even see it here. Block I, accumulator 0, array function. There we go. Perfect. So let's run to the next one. There we go. The accumulator is 1, accumulator is 3, accumulator is 6. Of course, we're going through I. I is now 4, accumulator is 10, and that's it. It returns 15. So I think that's hopefully, let me know in the chat, hopefully that sort of demystifies a little bit what reduce is really doing. Okay. The nice thing about, for example, or the easy thing about map or filter or similar functions is that the function that you pass to map or the function that you pass to filter, is a function that just takes a single argument, okay, which is the individual element each time, okay? Let's say you're mapping over a list of numbers and you're doubling them, for example. So each time around, the function that you pass to map just gets, 1, then 2, then 3, then 4, then 5 in our case, right? So the thing that messed with my brain a little bit was this whole accumulator thing, right? But hopefully that is a little bit more clear as to how reduce works. So now let's just play around with reduce a little bit more. So we could say, for example, reduce Helmut, Java, isn't this the language people used in the last century? Yes, Helmut, it is. Okay. I was for a while, sort of declaring that, Java is the new COBOL, which I guess is true in some ways, but anyway, I don't like to diss languages too much, but I'm not a fan of Java. The language Java, I've never been a fan of the language Java. Far too verbose, far too sort of restricting. I like loose languages. But anyway, that's another story. I do like other JVM languages, like Clojure, for example. That's a beautiful language, compiles to Java bytecode. So there we go. What's that thing you've shared there? TOB. Shall I click on that, Max? Let me know if I should click on that. Is that Java 2? Java 2. Java's only at version 2. Oh dear. Anyway, so let's try one more reduce. We've got the nums. We've got the nums here. So why don't we just double nums? Reduce, and let's have a function that takes an accumulator and the thing here. This pattern you will see this pattern the whole time. You can call these whatever you want. I call them A and X because I like X as a thing and A as the accumulator, right? And that returns. What are we going to do? Well, why don't we sort of string concatenate everything together. So let's say A plus X. In fact, let's sort of coerce. I have no idea what I'm doing here. A plus X plus a string, and then start with nothing. And well, actually, that should, if we start with nothing, there we go. And then nums. Let's see what happens. There we go. Ooh, well, we're still in the debug. Let's undebugify it. Continue. There we go. Go back to here. Get rid of the console. So there we go. So we've now sort of used sort of string concatenation in the sort of the wonderful loosely typed coercion thing with JavaScript. But there we go. We now sort of hopefully understand how reduce works. So now, why don't we say out of the way? Get these stickers out of the way. Why don't we say let's use reduce to bootstrap ourselves and implement other functions, okay? Because reduce is super powerful. Yeah, I will leave the recursive definition of reduce using head and the head tail thing, which was, yes, I won't share the slides from the inside track online track presentation. I'll do that keep that for another time. But it's definitely worth looking at. So let's use reduce, for example, to implement map. Okay, so map is a function that let's run this as a normal map. So nums.map, and we have a callback. So x times 2. Let's just double the things. Okay, so there we go. So there's map. So map takes a function and calls that function on each of the elements and returns the result. Okay, so with only very, very simple building blocks, it's almost like atomic building blocks, I think of them. We're going to implement map in reduce. So if we say map equals, what do we want to do? We want to, map is basically something that takes a function. In fact, we're going to implement it in the Lambda way, aren't we? So we're going to take a function and then the array. So let's say function and array. And let's implement it using reduce. Okay, we've got a starting value as well. So now and then that's the starting value. And also we want to put the array here. So let's see. What we want to do is we want to start, well, map. So the difference between reduce and all the other functions that we normally talk about is, as MDN said, it takes an array of things and produces a single value. That's sort of technically true, but single value sort of implies like a scalar value, like adding things together, or a string like 1, 2, 3, 4, 5 or 15. But actually, reduce can return any shape of object whatsoever. You can return an array, you can return a scalar, a string or a number or whatever, or you can return a map, as in an object. Right? So we're going to return, because map goes from an array to an array, right, of the same length. So let's start with the accumulator being an empty array. And all we need to do is each time around the loop, okay, the first time around, A is going to be that empty array. So we want to add on to that array. We want to concat, which is a beautiful function which just basically takes an array, A in this case, and adds on an element. Or you can actually concat, you can actually pass to the JavaScript concat, you can either pass a scalar value or an array. Okay, and it'll concat those array elements or that scalar value onto the existing array. So in fact, let's do that. Let's just do that. So if we've got, for example, here an empty array, concat hello, I'll just do that, and then we can say concat hello, and then concat, because what it does is return a new array. Okay, concat world. There you go. That's how concat works. So let's just do that here and say concat. And what do we want to add onto this array? We want to add the result of calling the function that we're given, this map function, on the individual x. And I think that should be it. Am I missing a bracket? Yes, I am. There we go. There we go. So we got a map function implemented using reduce. Does it work though? Okay, so let's say double equals takes a number and doubles it. Okay, so we can say now map double nums. Oh, length of undefined. Oh, hold on. I've done it wrong. Wait a minute. Map reduce a.concat. Oh, brackets. Sorry. There we go. I missed out a bracket there. I thought there was only one bracket at the end. Right, let's try that. There we go. We've now got a map function that works again in the same way, has the same sort of signature as a quote-unquote normal map function, i.e. a function that takes all of its arguments, rather than a function in the form of a prototype on the array object in more JavaScripty terms. So keeping things simple. So if you were to look at the Ramda definition of map, for example, I don't know where it is, Ramda map compose. Where's map? Why did it give me compose? Anyway, map there. Map is a function that basically, here's an example, takes double. There we go, double. Great minds think alike, fools seldom differ. So it takes a function and it takes an array and it returns another array. Okay, so that's what we're doing here with map. So now I've got another idea. Let's implement. I've got time. Yeah, let's implement filter with reduce. So it's similar. It's a similar sort of thing. Oh, here we go. The Java displaced by C. The TOB programming community index is an indicator of popularity of programming languages. Right. Oh, not Java version 2. Are you saying Java is in the second place? Helmut, how many classes would you create for this in Java? Max, yes. That's fighting talk, Helmut, and I like it. Okay, so I think we can implement filter. So filter is another function, same sort of signature as map, i.e. it takes, so filter will iterate through an array and only return elements of that array that where the predicate function, as in the function you pass, returns true. Okay, so everything we're talking about here, if you heard of the phrase higher order functions, we're talking about higher order functions here. Reduce is a higher order function, map, filter, everything, because they are functions that take other functions as arguments. For example, a higher order function is also a function, can also be a function that returns a function as an output, as a result. But anyway, we're going to define filter, and it's a function that takes a function and also an array. Okay, exactly the same sort of signature here, and we're going to implement it with a reduce. something, right? And because filter also has to return an array, okay, it might be an empty array if the predicate function returns no for all of the elements, okay, and we pass the array to reduce. Don't forget we're using our own reduce definition that we defined, so we've defined it from the ground up just using a for loop. We've defined reduce, and now we're using reduce to define other functions like filter and map. So, excuse me, this coffee is making me burp. What's going on? Maybe I'll have some water instead. Maybe it's because I didn't have a biscuit. There you go. There's a lesson. Always have a biscuit on HandsOnSAPDev. Oh, well, that is better actually. I'll have some more. Oh yeah. So where was I? Oh yes. So yeah. So we've got a for loop, very fundamental. We've got concat, which is also very fundamental, and that's all we're going to use. In fact, we're going to use concat again, aren't we? So what we're going to say is, let's call this predicate function on X, and if it's true, as in if the result of evaluating the call of the function, the predicate function that we're given, fn, on X, if that's true, then of course we want to include that element in the output array. So we want to say a.concat add X to the thing. Otherwise we don't. So we just pass whatever's in A right now. Okay, that should be all right. Let's try that. So nums is, there we go. Oh, let's define a function is even equals X, and we'll just say X modulo 2 equal to 0. So we can say is even 1, no. Is even 2, yes. Is even 3, no, etc. Right? So now we can say filter is even. I mean, we could have defined that sort of inline as a lambda function, anonymous function. But it's nice to have that. On nums, there we go. Let's just let's clear the screen, put it on the top. There. Where's our filter definition? There. Okay. There we go. So we've defined filter in terms of reduce. So if we'll have a look at reduce here, for example, we'll see as a clue, there's all sorts of different all sorts of different functions on the array prototype. Let's implement every method. The every method tests whether all elements in the array pass the test implemented by the provided function. It returns a Boolean value. Okay, so basically we can say, do all of the elements in this array pass this test? Okay, all of them. Okay, not just some of them, because there's a sum as well. There's every, there's also a sum. Okay, which is like test whether at least one element. So let's implement every. Okay, there we go. So every, and you can almost like see the pattern repeating itself again. Every is something that takes a predicate function. I mean, this is effectively a predicate function because it's going to return a Boolean true or false function. An array, right? Same thing. Reduce something. Okay, but now what does every return? Every returns a Boolean. Okay. So why don't we say, let's start with true. So the initial value, let's think glass half full, as it were. So every is going to return true as the initial value, but there's the array there, right? Okay. But what we want to do is we want to say, well, I think that, right? fnx. So what we're saying is that right? The first time around, let's take the numbers. Let's try, to see if every number in the numbers array is even. Obviously, it's not, right? So we'll start off with true. So true gets given in the first call to this reducer here. We've got true, and then x is 1. So we say the result of calling that particular function, that particular call, is true and is even 1. False. True and false is false. So the accumulator then becomes false. But if we start with 2, for example, or if we move 2, So true comes into A, and 2 is in X. So we get true ampersand ampersand is even 2, which is true. True and true is true. So the accumulator sort of remains true. So let's try that every. So we've got is even, which looks like that. So why don't we say every is even nums. Well, it's false, isn't it? Now, is that false because it's working, or is that false because it's not working? Why don't we say, I don't know, every, let's define a function here, x over, is x greater than 0, right? There's a function. True. Yeah, all of numbers in the array, nums, are bigger than 0. That's pretty cool. So there we go. There's every. Why don't we implement sum? Can we implement sum? Why not? How much time have we got? Oh yeah, I've got plenty of time. So are we all following here, by the way? Let me know. Let me know in the comments. Is this something that sort of is making sense to you? Is this something that's like worthwhile as something that's useful to what I find going back to basics, implementing things like reduce, which again, like I say, initially it was, this was a while ago now, but initially it was like, what, reduce? How does that work? It's bending my brain. What? But sort of taking the time to stare at what reduce really is all about and implementing it yourself, I think for me that was useful. So let's implement sum. In fact, sum is almost like every, right? So let's just do this. Sum, same thing. Thank you, Christian. Thanks for the confirmation. Same thing, but what does sum do? I can't remember. What does sum do? Let's go back here. Sum, test whether at least one. At least one. Now, okay, so that means that really, if we were implementing this like, I don't know, efficiently, we wouldn't really use it with reduce. Because with reduce, we're going to process all of the elements, right? But as soon as we hit like an element where the call with that element of the function returns true, then we can sort of abort and say, oh, okay, that's enough, But let's just, for the sake of argument, implement a very inefficient sum function with reduce. So it's almost the same, right? But I think basically we're going to start with glass half empty to say, well, yeah, no, none of them. But so if we've got here a or yes, I think it's just that, isn't it? If we say start out with false, and well, let's in my mind, let's do the is even. Is this going to be right? Is even. So first of all, we get false in A, and we get 1 in there. So we get false or the is even of 1, which is false. False or false is false. So we get false. Then we get a 2. Then the reduce function chooses the next element in the array, which is 2. And the accumulator is currently false because false or false is false. So we get false, and then x is 2. So we get false or is even 2, true. False or true, true. It's true. Yes, because false means that the or means that, okay, false, no, okay, well, let's try the other one, true. Yeah, true. And so on. Okay, so there we go. So let's try that. Sum is even nums true. Sum is even 1, 3, 5, 7, 9 false. Seems to work. So are we getting there? Are we getting there? So Peter, now what if we want to exit as soon as it's true? Well, with reduce, I'm not sure that that would be the right way to go about it. I suppose we could sort of what's the word I'm looking for? We could truncate the array so it wouldn't produce. I'm not sure, but I mean, this is pure, pure academic implementation of sum. Okay, I mean, because reduce processes all the items, we wouldn't really implement sum with reduce. But I think it's still useful as an academic exercise. Let's try something else. Let's try reverse. Could we do reverse? I think we could. Reverse. Reverse doesn't take anything, does it? Reverse just takes a list of things, right? So, oh, yes. So, if we say reverse takes just an array, right? We're not taking a function. Reverse doesn't take a function. So this is, slightly deviating from what we've been doing. But we're still going to implement reverse using reduce. Something. We're going to return an array, right? And just like map, reverse will or should produce an array of the same length, obviously. Just reversing the same thing, same values. And there's the array here. So what do? We're starting out with an empty array, but we want to sort of shove them in. We sort of want to sort of unshift. Don't forget, push and pop operate at the right-hand end of an array, right? You pop something off or you push something on, but shift pushes something onto the front of an array, and unshift pulls something off the front array. But we can sort of do that with concat, can't we? We could say, for example, oh, yes, we could say dot an empty array. We want to shove the things on the right. Yeah, there we go. Okay, so concat x, right? So we have an empty array, and the first thing in the result of this evaluated thing is going to be x as the first position. And then after that, we want to put in whatever is already in the array on the right-hand side. So we're sort of unshifting stuff on, right? Is that going to work? Reverse. Nums. Oh my God, it worked. Yes. So let's think about that. Why is that working? Because we start with an empty array, right? So the empty array goes into the accumulator. The first element gets called, the first element with which this function gets called is 1. So we take an empty array, we put 1 on there, and after the 1, we put anything else, which is nothing, okay? And that then becomes the accumulator. So we then got, as a result, an array with 1 in it. We go around again, so we got an array with 1 in it, and we get 2. So we take an empty array, push 2 onto it, then push 1 onto it, and then we got an array with 2, 1. We go around again, we got an array with 2, 1. We have 3 now in X. So we take an empty array, put 3 in it first, then put whatever's in A, which is 2, 1. We get 3, 2, 1, and so on. Yes. I think we're okay here. I think we're okay. What time is it? Oh my gosh, 8:59. That's it. Can you think of any other functions that we could implement with reduce like this in this bootstrappy way? Has that been useful? Let me know. Let me know in the comments. Let me know in the chat or comments or Twitter. And yeah, I guess that's it. I hope you enjoyed that. Yeah, I guess there must be other functions that we can implement in reduce, just to understand these things a bit more. But there we go. As the saying goes, reduce is the mother of all functions, or mother of many functions. It's such a beautiful, powerful thing. So have a wonderful Friday. Have a wonderful weekend. Stay safe, and I'll see you next week, hopefully, on the SAP Devs channel. Bye for now.